the sum, I used stars, and then since the sum must be 5, I had 5 stars. Assuming I was told that the sum of the numbers, that is the sum of the digits of the numbers, must be 6, I'm going to be using 6 stars. If I was told that the sum of the digits of the numbers must be 10, I would use 10 stars. Now again, since I've been told that the numbers are 2-digit numbers, then that implies that I must make sure that the first star is fixed. Now when the first star is fixed, it helps me to ensure that the first digit is not 0. So that implies that the only numbers I can arrange has to be the remaining digits, including the bar. So you note that the bar that we have here is only to split the first digits, that's to distinguish the first digit from the second digit. So all I did was, after I've known this, so since I know this is fixed, so how many bars or how many objects do I have left? I have 1, 2, 3, 4, 5, and then I have a bar. So that means I have 5 objects, 4 identical and 1. So how many ways can I arrange them? So just using the formula I explained in the video that I told you to watch is just going to give you 5. Now I'm going to use this analogy that I just explained here to find the number of 3-digit numbers, because that's going to be a little complex in trying to list all of them. So to find the number of 3-digit numbers such that their sum equals 5. So that's the next thing we are moving to now. So 3-digit numbers. So for the 3-digit numbers. Now for 3-digit numbers, so since we are told that the 3-digit numbers has to have a sum of 5, it must have a sum of 5, so that implies that we are going to have 5 stars. And also, since we are considering 3 digits, now for the case of a 2-digit, we had 1 bar just to distinguish the first and the second. But this time around, we need to distinguish both the first, the second and the third digit. So we would not need just 1 bar, but instead we would need 2 bars. Now for this problem, we need 5 stars and we need 2 bars. So an example of the symbolic representation here is, now since you have 5 stars, so what you're going to have is 1. So this is an example here. 1, 2, 3, 4, 5. Now this represents the sum. And then since you have, it must have 2 bars. So again, we note that the bar cannot fill this position here. So it's as if what you have here is fixed. So this is fixed here. So the remaining bars can fill the remaining positions. So you have 2 bars. So 2 bars can either be here or can be here. So what does this number, what does this represent? So let's see. So how many bars do we have? How many bars do we have here? So the bar we have here is how many? This is 1. Sorry, how many stars do we have? 1, 2. So this is 2. And between here and here you have 2 stars. And also between here and here you have 1. So that tells us that this symbolic representation, it represents 2, 2, 1, and which is correct, because 2 plus 2 plus 1 is 5, and this is a 3-digit number. Another representation is if you have star, so we said the sum must be 5, and then maybe what you did was you placed this time around your first bar was here, and then the second bar was here. So what number does this represent? So this represents, let's see, so how many stars do you have here? You have 1. How many stars do you have here? You have 3. And how many stars do you have here? You have 1. So this symbolic representation represents 1, 3, 1, which is correct because this is a 3-digit number and then the sum is 5. So again, you note that the first position cannot be the first position must be a star. That is, the bar can occupy the first position. Why? Assuming the bar occupy the first position, let us see the number that is going to end up with. So again, let's say you have the sum. So we are told that the sum must be 5. 1, 2, 3, 4, 5. And then the other condition is it's a 3-digit number, so we must have 2 bars. So if the bar fills this position, and then if you made a mistake of filling the bar in this position, so the number that this would represent is just going to be, so there's nothing here, so this is going to be 0. So you have 3 stars, this will be 3, and then you have 2 here. So what does this represent? It represents 0, 3, 2, and then 032 is the same thing as 32. But our aim is we want a 3-digit number. So that's to tell you that this bar here must not fill this position here. So in other words, all I'm trying to tell you is that in all our representation, the first bar must always be fixed. So where am I going to? So like we explained in the previous example, for the 2-digit number case, since the first position, that is the first digit, since it is fixed, so the only numbers or the only objects I have to play with is just this, this. So these are the only things I have to play with. So what I'm going to do is to find the whole set of numbers, 3-digit numbers that gives me a sum of 5. I need to consider the total number of possible arrangements of this 1, 2, 3, 4, 5, 6 of these 6 objects. So I'm going to consider the total number of arrangement, that is the permutation of these 6 objects. Now the 6 objects I have here, you have 6 objects. So you have six objects. Now my 6 objects contains how many stars? So you have 1, you have 2, you have 3, and then you have 4. So the 6 objects I have here, they contain 4 stars, and then you observe that the stars I have here, they are identical. So 4 identical stars. And then also, how many bars do I have? I have 2 identical bars. So it contains 2 identical bars. So the total number of possible arrangements of these 6 objects, given that 4 of the objects are identical and 2 are also identical, is going to be 6 factorial divided by, so since you have 4 identical, that'll be 4 factorial, another 2 identical, that'll be 2 factorial. And then when you do this, this is going to give you, so like we've explained, this is going to give you 6 times 5 times 4 factorial divided by 4 factorial times 2 times 1. So this goes off, and then 2 in 30 is going to give you 15. So that's going to give you 15. So in other words, just like we obtain here, when we use this technique, we obtain 5, which corresponds to the manual method here, which was 5. So this time around, instead of going through the manual process, I obtain my 15 directly using the technique I explained above. And then that tells us that the total number of 3-digit numbers such that they must give us a sum of 5 has to be 15. So now I have that. Now the next is I need to consider the last case. So we said we are considering 1, 2, 3 and now 4-digit numbers. So that's the last case I'm considering, the 4-digit number case. So that is 4-digit numbers. So you can pause this video and see if you can determine the number of stars and bars for the 4-digit case. Alright, welcome back. Now for the 4-digit case, so like we did here, so since we are told that the numbers, whichever numbers we must be considering, must have a sum of 5. So since it must have a sum of 5, then it's going to have 5 stars. And then also, we are told that it's a 4-digit number. So you observe that, look at the trend here. For the 2-digit number, we needed 1 bar to distinguish the digits. For the 3-digit number, we needed 2 bars to distinguish the digits. So that tells us that for the 4-digit number, we would need how many bars? We would need 3 identical bars. 3 identical bars. So as been explained before, an example is this. Maybe you had 5 stars. So this is 5 stars here, and then since you said you need 3 identical bars, so again for the 4-digit case, the first must be fixed. So since we said it must be, we need 3 identical bars, we just want to see what it's going to represent. So you have 1, 2, and let's say you have 1 at this position. So what does this number represent? So let's see, you have 1, 2, you have 2 stars, you have 1 star, you have 2 star, and then you have no star. So this is going to give you 2120. So which is correct? This is a 4-digit number and the sum is 2 plus 1, 3 plus 2, 5. So this is an example. So how many ways or how many 4-digit numbers can I have? Now to find number of 4-digit numbers such that the sum must be equal to 5, so all we need to do is, since we said this is fixed, so we shall be considering only the remaining ones. This is 1, 2, 3, 4, 5, 6, 7. So we want to consider 7 objects, the total number of ways of arranging 7 objects, and the 7 objects, they contain how many bars? So they contain 3 bars, 3 identical bars, and then how many stars do we have? 1, 2, 3, 4. So it contains 4 stars. So like we did here, the total number of arrangements of 7 objects given that 3 are identical and also 4 are identical is just 7 factorial divided by 3 factorial by 4 factorial, and when you multiply this you would obtain 35. So all in all, now I've already obtained 35. So 35 is the total number of 4-digit numbers plus 15. 15 is the total number of 3-digit numbers that have a sum of 5, and 5, which is the total number of 2 digits, and then 1. So the total number of numbers that we need is going to be, so you have 1 plus, so we have 5 plus, so we have 15 plus 35. 15 plus 35, and when we sum this up, this is going to give us 56. 1 plus 5, 6 plus 15, 21 plus 35, 56. So this is 56 is the total number of positive integers that satisfies 1 and 2 conditions. So that tells us that the solution to the problem is 56. It's a long problem, but if peradventure when you watch this video and you did not understand this thing the first time, I'm very sure when you watch it the second time you will have a very good grasp of what I explained here. Thanks for watching.